Hiya! Welcome back. We are still doing units 1 and 2, expressions and equations, but now we are just focusing on equations. So, last class you did a little review on 1 and 2 step and the properties. Today we're getting into the big one, the multi-step equations. So, let's go ahead and get started. Alright, so first we got to do some vocab. When we are solving an equation, we are finding a solution. It's the value for the variable that makes the equation true. I don't know why I'm talking like this. Sorry, I'm going to try to stop. And then when you're solving them, you can do a multi-step equation in 4 easy steps. To me, they're easy. I don't know if they're easy to you, but they will become easy. So step 1, distribute anything you need to distribute. Okay? Remember, it's always a number on the outside of the parentheses being multiplied with stuff on the inside of parentheses if you have to go. Once you hit that close parentheses, you stop distributing. Okay? Don't get a little too generous. We don't need to do that. Then we are going to combine any like terms that are on the same side of the equal sign. So if you have to jump over the equal sign to combine them, you can't do that. No. They have to be on the same side. They have to be part of the same expression. Okay? Step 3 is you want to get all your variables, and guys, paraphrase this if it's too long, because I know I get very wordy. Okay? Get all the variables on one side and all the constants on the other side, and we use the inverse property to do that. I'll show you what it looks like. And then step 4, isolate the variable and just get it by itself. Okay? So, if you need a minute, pause the video. Otherwise, let's move on. Example 1. So, here's an example where we have variables on both sides. So, 5a and a. We still go ahead and run through the steps, but it's a little bit more than just doing the 2-step equation. Okay? So first, there's nothing to distribute on either side. There is nothing to combine on this side because we have an a and then we have a constant. Here we have an a and a constant, so we can't combine anything. Okay? And then I'm going to walk and talk. So, sorry, I'm sitting right in front of my door and I don't want anyone to disturb me during this video, which tends to happen if they see me in my room. So, I'm going to walk over here. You probably don't need to know that I'm walking, but I am walking, and now I'm sitting, and that's your play-by-play of how I moved my desk. Okay, sorry. That was really bad. So, nothing to distribute, nothing to combine. So we go in, we have to get all our variables on one side of that equal sign, and all the constants on the other side. So, you can go ahead and start. You can either move the constants first, you can move the variables first. It's up to you. It really doesn't matter. I'm going to show you the way I like to do it. Doesn't mean you have to do it this way. If you like to do it a different way and you're not sure if it works and you want to show it to me next class, feel free. All that fun stuff. Some of you are like, just get to the math because all I want to do is write this down. And here I go. So I like to move the variable first. It's just, then it turns into a 2-step equation faster, and I know I can do that. So the variables I have are 5a and a. I'm actually going to choose to move the single a because it has a smaller constant, so if you think about it, like I'm moving less a's or whatever. So I want to move this one. Now, in order to move a variable, I still am going to use the inverse property. I need to try to create this into a 0. So to do that, I would actually subtract a from a, and that would create 0. So I'm going to subtract a from this side, and if I'm going to do it from this side, I have to do it from this side as well. Okay? And you guys can write this vertically, meaning up and down if you want, rather than across. I just had to do this because the computer wouldn't let me do it vertically. So I'm going to subtract a from both sides. Here, a minus a, those are my like terms. They combine to make 0. So I just have 8 left here. Over here, 5a and minus a, they can be combined to create 4a, and I still have my minus 8. So 4a minus 8 equals 8. Now it looks like a 2-step, so I can go ahead and do what I need to do. So I would add 8 to both sides. This is what I did here. Unfortunately, it's horizontally. Negative 8 plus 8 would give me 0, so I'm left with 4a, and 8 plus 8 gives me 16. Divide both sides by 4. I get a equals 4. Okay? Now, that is my solution, quote unquote. I'm not really sure yet because I haven't checked this to make sure. And I can, what's great about equations, that I can check to see if the answer I got is actually correct before making Miss Scully grade it. Okay? And I know I just referred to myself in third person. Leave me alone. I'm tired. So, I'm going to go ahead and take what A equals, supposedly what A equals, what I found that A equals, and plug it back into the original equation. And I should get something that's equal on both sides then. So I take it and I plug it in. So 5 times 4 minus 8 is equal to 4 plus 8. Do 5 times 4, I get 20. Then I do 20 minus 8 gives me 12. 4 plus 8 gives me 12. So because they came out equal, it's a true statement then. And 8 does actually equal 4. That is my correct answer. Okay? So that's how we do it. Example 2, same deal. Okay, I got nothing I need to distribute on either side. No like terms here, no like terms here, so I can't combine anything. So now I got to get my variables on both sides. I'm going to start by moving the single w. And to do that, I am just going to subtract w from both sides. So that the w's on this side would cancel out, leaving just 8. 7w minus w would give me 6w plus 2 equals 8. Now it's a two-step, so I would subtract 2 from both sides. That leaves me with 6w equals 6. Divide both sides by 6. I get w equals 1. And again, I want to make sure that this is correct. So I'm going to plug it back into the original problem. So 7 times 1 plus 2 is supposed to equal 1 plus 8. 7 times 1 is 7. 7 plus 2 is 9. 1 plus 8 is 9. So because it came out true, w does equal 1. Okay? Okay, if I went too fast, feel free to rewind, pause the video, whatever you need to do. This is like the only time you guys get to pause me and make me stop talking. So take advantage of it because it doesn't happen in class. So, all right. Now these two you're going to try on your own. Okay? And, is it just two? Yeah. These two I want you to try on your own and check your solution. Okay? Now if you get a false statement, like 12 equals negative 3 or something, that's clearly not true. Go back and check your work. Maybe you made a mistake with your inverse property, or you forgot a negative somewhere or something like that. Okay? So go back and check your work. Pause the video, do these two problems. We'll go over these in class. Okay, so hopefully you did A and B. You got an answer. When you checked it, it came out right. That's what should have happened. If not, make sure you make a note of it. We can go over it in class. Okay? Okay, example 3. Here's where all this stuff comes into play. So we start with distributing. Here, we actually have to distribute a 1, or I'm sorry, not a 1, a negative 1, because that's invisible. And we have to distribute a 2 on this side. So we go ahead and do that. And we get 5. That 5 just hangs out in front. Negative 1 times 2x gives me negative 2x. Negative 1 times 1 gives me negative 1. 2 times 4x gives me 8x. 2 times negative 3 gives me negative 6. Okay? Now that I've distributed, I actually find out I have like terms on this side that I want to combine. I don't have any like terms on this side, so I just leave it the way it is. So I combine the 5 and the negative 1 to make 4. So 4 minus 2x equals 8x minus 6. Okay? Now I'm going to go ahead and move some things around. To be very honest, when I made this, I can't remember what I moved first, so I believe it's the 8x. No, I moved it. Okay, so I stayed with the 2. I still stay with the lower coefficient. You could move this 8x first. You could move the negative 6 first. You can move the 4. It doesn't matter. Okay? So, but here I decided to add 2x to both sides. And the minus 2x plus 2x, that's going to create a 0. And then over here, it allows me to have like terms to combine. So these go away, leaving just 4. 8x plus 2x gives me 10x. Now it's a two-step equation, so I just go ahead and solve it. So I'm going to add 6 to both sides. What is going on here? Add 6 to both sides. And then it gives me 10 equals 10x. Then I divide both sides by 10. And there we go. And then I get x equals 1. Okay? So I want to go ahead and actually check to make sure this is correct. So I plug that x into all of these x's up here. If I can find it. There we go. So 5 minus 2 times 1 plus 1 equals 2 times 4 times 1 minus 3. This is GEMDAS I'm doing now. So I'm going to actually simplify what's inside the parentheses first. I don't distribute anything when I'm doing GEMDAS. When it's just numbers, don't distribute. So 2 times 1 gives me 2, 4 times 1 gives me 4, 2 plus 1 gives me 3, 4 minus 3 gives me 1. Okay, now 5 minus 3 gives me 2, 2 times 1 gives me 2. Oh, did that way. Comes out to be true, 2 equals 2. So 1 is my solution here. Okay? Example 4, same deal. I need to distribute first. The 3 to the 2, x ends in -1. So I get 3 times 2x gives me 6x, 3 times -1 gives me -3. Now I have like terms here. So I go ahead and combine those. So 7 minus 3 gives me 4 plus 6x equals 9x minus 8. I'm going to go ahead and move the 6x, I believe. Yep. Subtract 6x from both sides. So this 6x minus 6x will give me 0. So that's just going to leave me with 4. 9x minus 6x gives me 3x. So I get 4 equals 3x minus 8. Now it's just a two-step, so I add 8 to both sides. This will give me 12. The 8's will cancel out, leaving me with 3x. Divide both sides by 3. So I get x, x equals 4. And I can just test it to make sure it's right by plugging in for this x and this. So I plug it in, and now I just go ahead and simplify. 2 times 4 gives me 8. 9 times 4 gives me 32, which is the next step. No, it's not. 8 minus 1 gives me 7. Let's see what's next. 3 times 7 gives me 21. 9 times 4 gives me 36. 7 plus 21 gives me 28. 36 minus 8 gives me 28. So it came out true, which means that 4 is my solution. Okay? So again, you guys are going to try these two on your own. This one's a little bit more, okay? But that's okay. It's like our example. So go ahead and try these two on your own. Get a solution and check your solution, okay? If you don't get the same answer or it doesn't come out true, put a star next to it. We'll go over it in class. Okay. So you should have done these by now. If you haven't, pause the video and do it now. Okay? So these we'll go over in class. All right? And that's it. That was it. Sorry. I thought there was more. All right. If you have any questions, make sure you ask them in class. Otherwise, I will see you next class. Bye.